Tom's legs felt heavy as he walked through the shining metal hallways of the Galactic Academy of Sciences. Each step was a careful balance between not pushing too hard and not floating away in the space station's low gravity. The 15-year-old human had spent weeks practicing in Earth's gravity simulation chambers, but the real thing was different. A group of tall, blue-skinned aliens floated past him with perfect grace, their 4 arms moving in smooth patterns through the air. They whispered among themselves, their large eyes fixed on Tom's bulky gravity boots. One of them made a sound like tinkling crystals, probably their version of laughter. "Just ignore them," Tom muttered to himself, clutching his old paper notebook tighter. He was the first human student ever accepted to the academy, and he wasn't going to let a few stares ruin this chance. The classroom door slid open with a soft hiss. Inside, 20 alien students sat at floating desks, each one different from the others. Some had scales, others had fur, and a few seemed to be made of living crystal. They all turned to stare at Tom as he entered. "Ah, the human student arrives." The teacher's voice came from above. Mr. Blue, as Tom had been told to call him, floated down from the ceiling. His transparent body pulsed with patterns of light as he spoke. "You're late." "Sorry, sir," Tom said, trying to keep his voice steady. "I'm still getting used to the gravity boots." More crystal-like laughter filled the room. Mr. Blue's lights flickered in what Tom guessed was amusement. Understandable. Deathworlders often struggle with our more advanced environment. Mr. Blue gestured to an empty desk. "Please take your seat. Try not to break anything with your enhanced muscle density." Tom walked carefully to his desk, aware of every movement. On Earth, he was just a normal kid who liked physics and space. Here, his enhanced muscle density and Deathworlder biology made him feel like a bull in a china shop. "Now, class," Mr. Blue continued, his body glowing brighter. "Today we begin our study of planetary physics. Since we have a diverse class this year, we'll start with something simple." His lights pulsed directly at Tom, something even a human can understand. The holographic display in the center of the room lit up with complex equations. Tom recognized them: escape velocities and gravitational constants. Basic stuff he'd learned in his Earth physics class. "Your homework," Mr. Blue announced, "is to calculate the escape velocities for the 10 planets displayed here." The alien teacher paused, his lights dimming slightly. "And since we have a student from a less advanced world, you may use your quantum computers for this simple task." A small gray alien in the corner raised one of its tentacles. "Sir, isn't this too easy? My computer can solve these in microseconds." "Precisely." Mr. Blue's lights rippled. "But we must accommodate all levels of development." He turned to Tom. "You do have a quantum computer, yes?" Tom shook his head. "No, sir. Just my notebook and calculator." The room fell silent for a moment before erupting in that crystal chime laughter again. Even Mr. Blue's lights sparkled in amusement. "Well," the teacher said, "do try your best with your primitive tools." Class dismissed. As the alien students floated elegantly toward the door, Tom looked down at his notebook. A smile crept across his face. They thought these calculations were just about plugging numbers into a computer. They had no idea what it meant to really understand planetary physics. Tomorrow was going to be interesting. Back in his small dormitory room, Tom spread out the homework details on his desk. The holographic display from his standard-issue school tablet showed 10 planets rotating slowly in the air. Each one was different. Some were gas giants with swirling storms, others were rocky worlds with thick atmospheres, and a few were small, airless moons. "Let's see what we've got here," he mumbled, pulling out his pencil and notebook. The first planet looked a lot like Jupiter, but with 3 rings instead of 1. Its datasheet showed its mass, radius, and atmospheric composition. A soft chime rang through his room. "Hey, Deathworlder," a voice called out. The crystal-bodied alien from his class, who Tom now knew was named Bright, appeared on his room's communication screen. "Having fun with your ancient counting tools?" Behind Bright, Tom could see several other classmates lounging in what looked like a study room. They were all holding their quantum computers, sleek devices that seemed to float between their fingers. "My quantum comp just finished all 10 calculations," another alien student shouted from the background. "Took it whole 3 microseconds. Must be getting slow." They all laughed their crystal chime laugh. Tom smiled politely. "Thanks for checking on me. I'll manage." "We're having a study session," Bright said, his crystalline body gleaming. "You can join us if you want. Someone might let you borrow their spare quantum comp. You know, if you can figure out how to use it with those thick fingers of yours." "I'll stick with my method, but thanks," Tom replied, turning back to his notebook. After the call ended, Tom looked at his Earth physics textbook, an actual paper book he brought from home. His old teacher, Mrs. Green, had written something on the first page. Understanding beats memorizing every time. He started with the first planet. Instead of just plugging numbers into a formula, he drew a diagram showing all the forces at work. The gas giant's atmospheric drag would affect the escape velocity. Its 3 rings meant there were additional gravitational interactions to consider. The planet's rapid rotation would also change the effective escape velocity at different latitudes. Hours passed as Tom worked through each problem. His notebook pages filled with drawings, calculations, and notes. For each planet, he wrote out not just the final escape velocity, but also how it would change under different conditions. What if you launched from the poles instead of the equator? What if the launch path went through one of the rings? What if you used the atmosphere for a gravity assist? By the time he reached the last planet, a small, dense world with a highly elliptical orbit, his hand was cramping from all the writing. But he felt good. Each calculation told a story, showed the actual physics at work, rather than just a final number. The room's lighting had shifted to night mode when Tom finally finished. He looked at his work. 10 pages of detailed calculations and explanations, all done by hand. Next to each solution, he'd added practical notes about what the numbers actually meant for spacecraft trying to leave these planets. "Wonder what Mr. Blue will think of this," Tom said to himself, carefully putting his notebook away. He glanced at the quantum computer catalog the school had given him. The price was more than his family made in a year, but right now, he was glad he didn't have one. Tomorrow, he would show them that understanding the physics behind a problem was worth more than having a fast computer. As his dad always said, any machine can give you an answer. Knowing why it's right is what matters. Tom went to bed smiling, dreaming of the surprised looks he hoped to see on his classmates' faces when he presented his work. Morning came quickly on the space station, with artificial lights brightening to simulate dawn. Tom sat at his desk, reviewing his calculations one last time before class. As he flipped through his notebook pages, his mind wandered back to his last day at Earth's Space Academy prep school. "Remember, Tom," Mrs. Green had said, packing up her old physics books for him. "They'll have technology we can only dream of out there. But never forget, understanding the why is just as important as knowing the what." A warning chime pulled him back to the present. He had 20 minutes to get to class. This time, Tom moved more confidently through the station's corridors, his gravity boots making solid contact with each step. A week of practice was already making a difference. In the classroom, the alien students were gathered in small groups, their quantum computers projecting colorful holograms of planetary orbits. Tom took his seat quietly, but noticed something different today. A few curious glances rather than the usual mocking stares. Mr. Blue materialized at the front of the room, his transparent body glowing with anticipation. "Class, today we share our homework results. Who would like to go first?" Bright's crystal hand shot up immediately. He floated to the front, his quantum computer projecting a massive hologram showing all 10 planets at once. "The escape velocities are as follows," he announced proudly. Numbers appeared next to each planet, precise down to 100 decimal places. "Excellent precision," Mr. Blue's lights pulsed approvingly. "Next." One by one, The alien students presented their results. Each showed the same perfect numbers, calculated to incredible precision. Some had even added animations of theoretical spacecraft, leaving the planet's surfaces. Tom used the time to think about Mrs. Green's last lesson before he left Earth. They had launched small rockets on the school field, measuring their velocities with simple tools. "See how the wind changes things," she had said. "Real physics isn't just numbers on a page. It's understanding all the little things that affect those numbers." And finally, Mr. Blue's voice brought Tom back to the present. "Let's see how our Deathworlder managed with his traditional methods." Tom walked to the front of the room, his notebook in hand. Instead of projecting holograms, he put his hand-drawn diagrams under the room's document scanner. The first image appeared on the classroom screen, a detailed sketch of the gas giant with its 3 rings, covered in notes and arrows. For the first planet, Tom began, the basic escape velocity is 59.3 kilometers per second. But that's just the beginning. He pointed to his diagrams. The planet's rapid rotation means this number drops by up to 8% at the equator. The 3 rings create gravitational interference patterns that can either help or hurt a launching spacecraft. The room was silent. Even Mr. Blue's usual pulsing lights had steadied. Each ring, Tom continued, drawing on his diagram with a light pen, creates a gravitational gateway. If we time the launch right and use these gateways, we can reduce the needed escape velocity by another 12%. But timing is crucial. Launch at the wrong moment, and the rings will tear the spacecraft apart. He flipped to his next page. The atmosphere is even more interesting. These gas layers create drag, which usually works against us. But if we plot the right course, Tom drew a curved line through his atmospheric diagram, we can use that same drag to generate lift, cutting our energy needs by up to 15%. Tom looked up. The alien students were no longer lounging in their seats. They had moved closer, their various eyes, sensory organs, and scanning appendages focused intently on his drawings. Even Bright's crystal body had taken on a darker, more serious hue. Mr. Blue floated forward, his lights now pulsing in an unfamiliar pattern. "And the other planets?" he asked quietly. Tom took a deep breath and moved to his next diagram. The second planet was a rocky world with a thick, stormy atmosphere. His detailed drawings showed wind patterns and electrical storms that the other students' quantum computers had completely ignored. "This one's particularly tricky," Tom said, pointing to the swirling storm patterns he'd drawn. "The atmosphere has layers of supercharged particles. Hit them wrong, and they'll fry your ship's electronics." But he drew another curved line through the layers. "If you time your launch to use these electromagnetic currents, they can actually help boost your velocity." A small gray tentacled student raised an appendage. "But our quantum computers show the escape velocity as exactly 32.76599403. "That's the theoretical number," Tom interrupted politely. "But in real life, you'd never actually achieve that. The storms would tear your ship apart." He flipped to another page of calculations. "You need to aim for 36 kilometers per second to have a safety margin, and you have to launch during the planet's winter season when the storms are weaker." Mr. Blue's lights had changed to a deep blue color Tom had never seen before. "Continue," the teacher said softly. For the next 20 minutes, Tom walked through each planet's unique challenges. The ice world where traditional rockets wouldn't work because the exhaust would instantly freeze. The binary planets where you had to thread your launch path through their competing gravitational fields. The small moon where the biggest challenge wasn't getting off the surface, but avoiding getting pulled back by its larger neighbor. The alien students had completely abandoned their usual floating positions. They clustered around Tom's desk, some using their sensory organs to take detailed scans of his drawings. Bright had actually picked up Tom's pencil, awkwardly with his crystal fingers, and was trying to copy one of the diagrams. "And that brings us to the last planet," Tom said, showing his final set of calculations. "This dense little world with the elliptical orbit." He pointed to his orbital diagram. The quantum computers give us one escape velocity, but that number changes by up to 40%, depending on where the planet is in its orbit. Launch at the wrong time, and you'll either waste huge amounts of fuel or crash right back into the surface. The room was completely silent. Even the usual background hum of the space station seemed muted. Mr. Blue floated down to examine Tom's notebook more closely. "In all my cycles of teaching," he said, his voice modulating strangely, "I have never seen anyone approach the problem this way. Your numbers are not as precise as the quantum computers, but they're more useful." Bright suddenly interrupted. His crystal body had turned a deep, thoughtful blue. "Our computers just gave us perfect numbers for perfect conditions. These calculations," he pointed to Tom's diagrams with a crystalline finger, "these show us how to actually fly through these systems." "Precisely." Mr. Blue's lights pulsed rapidly. "It seems we have all made an incorrect assumption about primitive methods." He turned to face the class. "Who can tell me why the humans' approach might be more valuable than our standard computational method?" The gray-tentacled student waved excitedly. "Because spaceflight isn't just about the numbers. It's about understanding all the forces involved and how they interact. And how did none of us think about the storms?" Another student added, "Or the ring interactions. Our computers gave us mathematically perfect answers for physically impossible situations." Tom stood quietly, watching as his classmates began animatedly discussing all the real-world factors they'd never considered before. Mr. Blue's lights had settled into a steady, bright glow. "Perhaps," the teacher said, "it is time we reconsidered our definition of advanced calculation methods." News spread through the Galactic Academy faster than light-speed communication. By lunch break, students from other classes were stopping by to look at Tom's notebook. The cafeteria buzzed with excited discussions about the human method of solving physics problems. Tom sat at his usual corner table, trying to eat his Earth-standard lunch, while a group of crystalline students like Bright practiced drawing diagrams on their tablets. They had abandoned their quantum computers for the moment, instead attempting to understand the principles behind orbital mechanics. "But how did you know to consider the storm patterns?" A purple, gas-based student named Mist floated nearby, their form swirling with curiosity. "The quantum computers don't even have that in their databases." Tom swallowed his sandwich bite. "On Earth, we learned about spaceflight by actually doing it. We lost many early rockets to weather, mechanical problems, and calculation errors. Each failure taught us something new." "Fascinating," Bright said, his crystal structure reflecting light in complex patterns. "We've always relied on our computers to be perfect. We never considered that perfect calculations might miss real-world problems." The cafeteria door slid open, and Mr. Blue floated in, accompanied by several other teachers. Their bodies glowed with various colors as they approached Tom's table. Among them was the head of physics, a being made of pure energy contained in a special field. "Young human," the head of physics spoke, their voice resonating through the air, "your homework submission has caused quite a stir in our faculty meeting." They gestured to Tom's notebook, which had been scanned and shared among the teaching staff. "We've been teaching planetary physics the same way for 300 cycles." Tom felt his face grow warm. "I'm sorry if I did something wrong." "Wrong?" Mr. Blue's lights pulsed brightly. "Quite the opposite. You've shown us a blind spot in our teaching methods. We've become so reliant on quantum computation that we've forgotten the importance of understanding fundamental principles." The head of physics produced a holographic display showing Tom's calculations alongside traditional quantum computer results. "Your method takes longer and is less precise in pure mathematical terms. However," they zoomed in on Tom's notes about atmospheric conditions and ring interactions, "your results are far more practical for actual spaceflight." Other students had gathered around now, their various sensory organs focused on the discussion. Tom noticed that many of them had started carrying paper notebooks alongside their quantum computers. "But that's not the most interesting part," Mr. Blue added, his transparent form glowing with excitement. We ran your calculations through our most advanced simulation systems. Your hand-drawn launch trajectories for avoiding the ring interference patterns. They're actually 7% more efficient than the standard routes our computers calculate. A wave of surprised murmurs swept through the cafeteria. Some of the floating students had to adjust their altitude stabilizers. How is that possible? Bright asked, his crystal form vibrating with curiosity. Because, the head of physics explained, the human method considers the entire system at once, not just the mathematical ideals. Sometimes, a less perfect trajectory that accounts for real conditions works better than a mathematically perfect one that ignores them. Tom looked down at his simple notebook, then at all the advanced alien technology around him. My old teacher always said that understanding beats memorizing. I guess that's true even with quantum computers. Mr. Blue's lights formed a pattern that Tom recognized as a smile. Indeed, and speaking of your old teacher, he produced a holographic communication request form. The Academy would very much like to discuss education methods with her. Perhaps it's time we learned some primitive techniques ourselves. A month had passed since Tom's homework presentation, and the Galactic Academy of Sciences had changed in ways nobody expected. Walking through the hallways now, Tom saw alien students sitting in study groups with paper notebooks spread out alongside their quantum computers. Some were even using pencils, though many needed special adaptations to hold them with their various appendages. In Mr. Blue's class, the morning started with an unusual announcement. Today, the teacher's lights pulsed with excitement. We begin our new combined learning approach. Please activate your quantum computers. He paused, his lights twinkling, and take out your notebooks. The class had been rearranged. Instead of individual floating desks, students now sat in mixed groups. Tom found himself at a table with Bright, Mist, and two other aliens he'd gotten to know over the past month. Their table was covered with both high-tech displays and hand-drawn diagrams. Our topic today is spacecraft design, Mr. Blue announced, projecting a hologram of various ships in the center of the room. Your quantum computers can calculate the perfect engine thrust ratios, but first, he displayed a simple sketch that looked very much like Tom's style. We'll understand why these ratios matter. Tom watched in amazement as Mr. Blue began teaching the way Mrs. Green had back on Earth, starting with basic principles and building up to complex calculations. The alien students were fascinated, especially when they discovered how understanding the fundamentals helped them spot problems their computers missed. Tom, Bright whispered, his crystal body glowing softly, can you help me with this thrust vector diagram? My quantum computer says the numbers are perfect, but something doesn't look right about the fuel consumption. Tom leaned over to look at Bright's work. See how you've got the engine positioned. In theory, it's the most efficient angle, but he sketched a quick diagram. In real conditions, that would create turbulence in the fuel flow. Sometimes, the mathematically perfect solution isn't the best practical one. Around the room, similar scenes played out. Students who once relied solely on their advanced technology were now eagerly discussing real-world applications and practical limitations. Even the learning AI that helped manage the class had been reprogrammed to consider practical experience alongside pure mathematics. During lunch break, Tom visited the Academy's main hall and stopped in surprise. The large display screen that usually showed quantum physics equations now featured a quote, "Understanding beats memorizing." Earth educator Sarah Green. Below it, a steady stream of students from all years flowed into a new classroom labeled Practical Applications and Fundamental Principles. "Quite a change you've started," said a familiar voice. Tom turned to see the head of physics floating nearby. "We've had to restructure our entire curriculum. Did you know that 17 other galactic academies have requested our new teaching materials?" "I never thought," Tom began, "that primitive methods could improve advanced education." The energy being's field rippled with amusement. "We've learned that true advancement comes not from having the most powerful tools, but from deeply understanding how to use them." The head of physics gestured to a group of first-year students practicing with both quantum simulators and physical models. Your homework didn't just solve some physics problems, Tom. It showed us that we have forgotten something important in our rush to embrace advanced technology. What's that? Tom asked. That the universe doesn't care how advanced your calculator is. It follows the same laws whether you use quantum computers or pencil and paper. Understanding those laws, truly understanding them, that's what makes a good scientist. The end of break bell chimed, and Tom headed to his next class, passing more students with their curious mix of ancient and advanced tools. He smiled, thinking about how a simple homework assignment had changed the way an entire galactic civilization thought about learning. 3 months after Tom's famous homework submission, the Galactic Academy's main docking bay was buzzing with activity. A small Earth transport ship had just arrived, carrying the second-ever human student to attend the Academy. Tom stood with Mr. Blue and a group of alien students, waiting to greet the newcomer. Nervous about not being the only human anymore. Bright asked, his crystal form shimmering with friendly colors. He was holding what looked like a welcome gift, a package containing both a quantum computer and, amusingly, a set of Earth pencils. A little, Tom admitted, adjusting his now well-worn gravity boots, but mostly excited. It'll be interesting to see how different the welcome is from when I arrived. Mr. Blue's lights pulsed gently. Indeed. Though I must admit, I feel some shame about how we first treated you. His transparent form shifted to a humble blue shade. We were so certain that advanced technology meant advanced thinking. The docking bay doors opened with a soft hiss. A young human girl walked through, looking just as awkward in her gravity boots as Tom had 3 months ago. She clutched a notebook in one hand and a tablet in the other, her eyes wide as she took in the alien crowd. But instead of whispers and crystal chime laughter, she was greeted with genuine warmth. A group of first-year students rushed forward, eager to show her their own notebooks filled with hand-drawn diagrams alongside quantum calculations. "Welcome to the Galactic Academy," the head of physics announced, their energy form glowing brightly. "You'll find we do things a bit differently here now. We believe in combining the best of all methods, both advanced and fundamental." Tom watched as the new student was surrounded by friendly aliens, all eager to share their experiences with the new combined learning approach. On the walls of the docking bay, screens displayed both complex quantum equations and simple physics diagrams. One screen showed a live feed from the Academy's new Practical Applications Lab, where students were building small test rockets using both ancient and advanced techniques. "It's amazing how much has changed," Mist said, their gaseous forms swirling thoughtfully. "Did you know the Galactic Science Council is now requiring all schools to include fundamental understanding in their curricula? They're calling it the Deathworlder initiative, though maybe we should find a better name." Tom laughed. "Maybe just call it Understanding First." Speaking of understanding, Mr. Blue interjected, his lights forming what Tom now recognized as a proud smile. "Your old teacher, Mrs. Green, has been an incredible help. Her virtual lectures on teaching methods have become mandatory viewing for all galactic educators." The new human student was now showing her notebook to the alien students, who were comparing her diagrams with their own. Tom could hear excited discussions about different ways to visualize gravitational fields and energy flows. "You know what the funny thing is?" Bright said, his crystal surface reflecting the docking bay's lights. "We thought we were so advanced, but we had forgotten the most basic principle of science: curiosity. We let our computers do our thinking for us. You humans, with your primitive methods, reminded us what it means to really want to understand something." The head of physics floated forward. "The universe is vast and complex. No single species, no single method has all the answers. True advancement comes from combining different perspectives, from being willing to learn from everyone, even those we once thought primitive." Tom watched as the new student was led away by her enthusiastic welcoming committee, already deep in discussion about combining Earth physics methods with alien technology. In just 3 months, a simple homework assignment had grown into something that was changing education across the galaxy. "Ready for your next class?" Mr. Blue asked. I believe you're teaching the Advanced Practical Applications seminar today. Tom nodded, picking up his well-worn notebook and his newly acquired quantum computer. Ready, though I still think understanding beats memorizing every time. Indeed it does. Mr. Blue's lights pulsed warmly. Indeed it does.